Hello everyone, I am Dr. P.K. Bharti. In my first video, I explained in detail about binomial distribution, which is applicable for probability prediction of those events in which chances of failure and success both are known, with only two possible outcomes. In this video, I will discuss Poisson distribution with few solved examples. Unlike binomial distribution, Poisson distribution is used for probability prediction when chances of happening of an event are rare or very small, while number of times event did not occur is not known or cannot be counted. There are certain circumstances in which number of times an event has occurred can be counted, but number of times event did not occur is either meaningless or it cannot be counted. For example, number of typing mistakes committed by a typist. This can be counted, but number of times the typist has not committed the mistake cannot be counted. Similarly, the number of goals scored by a football team in a match can be counted, but number of chances the football team has missed the goals cannot be counted. Or number of persons dying due to a rare disease can be counted, but number of persons who has not suffered from the rare disease cannot be counted. In such situations, Poisson distribution can be used for determining probability of success. Poisson distribution can be used to calculate the likelihood that the specific event will occur a certain number of times over a period of time. Poisson distribution is a discrete distribution which describes random events that rarely occur over a unit of time or space. As we have already discussed that unlike binomial distribution in which we count the number of successes and number of failures, in Poisson distribution we count the average number of successes in a given unit of time or space. We can say that Poisson distribution is the limiting case of binomial distribution under the following assumptions. First, the number of trials n should be indefinitely large, while in binomial distribution, the number of trials n has a finite value. Second, the probability of success p for each trial is indefinitely small. And third, np equal to lambda, where lambda is a shape parameter. The value of lambda should be finite and is a constant. Though the Poisson distribution is applicable in many situations for many type of events, we will discuss here few of them. First, Poisson distribution may be used to determine the number of defects in quality control statistics. That is, Poisson distribution can be used to determine the number of defects produced in a production line. Poisson distribution can also be used to count the number of bacteria in biology. This distribution can also be used in determining the number of deaths in a district or in a state or in a country or world in a given period of time because of a rare disease. Apart from this, we can also calculate the number of plants which are infected with a particular disease in a given period of time in a particular plot or field or area. The relation which is used to calculate the probability of happening exactly X events in a given time is as follows. This relation is also known as probability mass function of Poisson distribution. Px equal to e to the power minus lambda, lambda to the power x upon factorial x. where x can have the value 0, 1, 2, 3, and so on. Lambda is a shape parameter which indicates the average number of events in the given time interval. Lambda is also the average number of occurrences per unit of time, and it is equal to np. So now we will see how to apply Poisson distribution with the help of few examples. We will go through the problem 1. The chances that an individual coal miner being killed in a mine accident during a year is 1 by 1400. Calculate the probability that in a mine employing 350 miners, there will be at least one fatal accident in a year. Here we can say the probability of happening, that is probability that a miner will be killed in an accident during a year, is 1 by 1400, which is very small. And the total number of employees are 350. So here we can say for applying Poisson distribution, n will be 350, while p, the probability of happening, will be 1 by 1400. To solve this problem, we will apply the probability distribution, which is px equal to e to the power minus lambda, lambda to the power x upon factorial x. As we have already discussed, we can calculate lambda as n into p. N is 350 and probability of happening is 1 by 1400. So this way we get lambda as 0.25. Since we have to calculate the probability that at least one miner being killed in a year, we have to calculate Px is either equal to or greater than 1, which will be equal to Px equal to 1 plus Px equal to 2 plus Px equal to 3 and so on up to 350. Obviously, this equation will be very long. It will not be easy to solve this equation. Therefore, we will go for an alternate approach as p x equal to greater than 1 will be equal to 1 minus p x equal to 0, where p x equal to 0 means the probability that no miner is being killed in accident in a year. Here, for px equal to 0, we will apply Poisson distribution e to the power minus lambda, lambda to the power x upon factorial x. So this way we will get px equal to greater than 1 is equal to 1 minus 0.78. That is 0.22. Here we can say that 22% chances are there that at least one fatal accident will occur in a year. Now we will go through solved example 2. Suppose on an average one house in 1000 in a certain district has a fire during a year. If there are 2000 houses in that district, what is the probability that exactly 5 houses will have a fire during the year? So here we can see the probability that a house will have a fire during a year is 1 upon 1000, 1 in 1000 houses, which is very small. That is, probability of happening is very small. And there are 2000 houses. N will be equal to 2000. To solve this problem, we can see here, we can calculate lambda equal to NP, 2000 into 1 by 1000, that is 2. We will apply Poisson distribution to calculate the probability that exactly 5 houses will have fire during the year. So we will apply this Poisson distribution Px e to the power minus lambda, lambda to the power x upon factorial x. So Px equal to 5, e to the power minus lambda means e to the power minus 2 into 2 to the power 5 upon factorial 5. After solving this, we get 0.036. That is, probability that out of 1000 houses, out of 2000 houses, 5 houses will have a fire during a year is 3.6%. As we have already discussed that we can use Poisson distribution for prediction of defects in a manufacturing line also. So here in example 3, we will see how to calculate the number of defective items in a lot. Here we can go through the problem. If 2% of electric bulbs manufactured by a certain company are defective, find the probability that in a sample of 200 bulbs, less than 2 bulbs are defective. Here we can see probability of defective bulbs is 2%. That is 2 by 100. P is equal to 2 by 100, 2%. And N equal to 200. So we have calculated here lambda N into P 200 into 2 by 100, that is 0.02 equal to 4. And N, obviously there are 200 bulbs, N will be 200. To calculate that less than 2 bulbs are defective in a sample of 200 bulbs, we can apply Poisson distribution. Px equal to e to the power minus lambda, lambda to the power x upon factorial x. Since we have to calculate the probability that less than 2 bulbs are defective, we will calculate the probability that no bulb is defective plus the probability that one bulb will be defective. If we add these two probabilities, we will get the probability that less than 2 bulbs will be defective. So for P x equal to 0, we have applied here Poisson distribution e to the power minus lambda, lambda to the power x upon factorial x. Similarly, probability that one bulb will be defective in the lot can be calculated by applying Poisson distribution e to the power minus 4 into lambda to the power x upon factorial x. After solving this, we get it as 0.0915. Here we can say that probability that less than 2 bulbs will be defective in a sample of 200 bulbs is 9.15%. Or we can say 9.15% chances are there that in a sample of 200 bulbs, less than 2 bulbs will be defective.